Welcome to Pomodoro Joe for Friday, April 28th, 2023. Today we're doing LeetCode problem 839, similar string groups. This is a hard problem. So two strings, x and y, are similar if we can swap two letters in different positions of x so that it equals y. Also, two strings x and y are similar if they are the same. For example, tars and rats are similar, swapping at position 0 and 2. So let's see, 0 is T and R, so yep. And rats and arts are similar, but star is not similar to tars, rats, or arts. Together, these form two connected groups by similarity. Tars, rats, arts is one group, and stars is another group. Notice that tars and arts are in the same group even though they are not similar themselves. Formally, each group is such that a word is in the group if and only if it is similar to at least one other word in the group. We are given a list, strs, of strings where every string in strs is an anagram of every other string in strs. How many groups are there? Oh, right, so this is tricky. We have up to 300 strings. We have up to 300 strings, and each string can be up to 300 characters long. It's only lowercase letters, and all words in strs have the same length and are anagrams of each other. So that's good. Okay, so with this, we'll put 25 minutes on the Pomodoro timer, and we will get started. So I'm going to break this down into pieces. We'll build those up into our final solution, and then I will explain maybe a better way to do it. I don't have time to go through the better way at the moment. So first thing we'll do, we'll have some result, we'll set it to 0, and we will return our result at the end. All right, the next thing I think I want to do is have some basic understanding of what similar words are. So I'll create a function here that will actually take in two words and return true or false whether or not these two words are similar. So let's say are similar. Okay, so we know two words are similar if they're the same, so we can do something simple. All right, if they're the same, we'll just return true. We also know they're similar if we can swap two characters and have the two words match. So I'm going to keep track of which characters are not the same, and then we'll have to check to see which characters, if they aren't the same, can we swap. So I will go through each of these words looking for characters that do not match, and I'll record their index. So I'll keep track of which indices are not matching characters. Then I have to go back and check if I swap those characters, would these two words be the same? So let's do that. So I'll just keep an empty array of the non-matching indices. That way, if it's less than 2, or if it's not equal to 2, well, then we can return false. If it's equal to 2, then we just check to see if we can swap those two indices to get matching words. So we'll go through, for every matching index and character in the enumerated word 1, we'll check to see if that character is not equal to the matching character in word 2. If they don't match, then we'll record that index in our non-matching indices. Okay, once we get out of this loop, we can check right away if the length is less than or not equal to 2. We can check right away if the length of this is not equal to 2, then we'll return false. Now, you're thinking, well, what if it's 0? Well, we should have handled that case up here. Okay, if it is equal to 2, well, now we have to check to see if we swap those characters, do we have matching words? So let's just check to see if those swaps would be equal. All right, so I'm just going to check to see if the character at index 2 for word 1 matches the character at index 1 for word 2. And if the character at index 1 for word 1 matches the character at index 2 for word 2. So that would be the swap. So now we have this are_similar function. So that should help us out a little bit. Next thing we need to do, let's go through and find all the words that match each other. So we'll basically go through every word in our list of words and we'll compare it to all the other words. Then we'll have to keep track of which words are similar, and so I'll keep track of that in an array. I'll call this groups. So this will be a mapping of the index of the word to a group label. So we're not actually going to keep track of sets. We're not going to put our words into sets. We're just going to have a labeled group. So for example, we'll have group 1 and we'll just have this array, and any word that is in group 1 will have 1 in this array. Any word that's in group 2 will have a 2 in this array. So for this we'll have, let's see, what do I want to start it out as? I think I can just have it none. They're not in any groups to start with. Okay. Now, for every word, I think I want to keep track of which index I'm at. So for every index and word in my enumerated strings, first we'll check to see, do we already have a group for this word? If we don't, then we'll add one. I think I'll make this actually a singular, just group. So if we don't yet have a group for this word, we'll just create one. And the label will just be our result plus 1. So that's going to be our greatest number of groups so far. It doesn't really matter what this is as long as it's unique. So now we've created some unique group label for this word. Now we'll go through all the other words, compare them to this word. Now I'll just be going through from this word's next word and forward. So I don't want to compare words that I've already compared before. So we're just going to look forward in our list. So we'll go from, let's see, this will be I plus 1 to the end of our string list. So now we'll just check to see if they're similar. So we have this function here. Let's see, I can't call this I, call it J. So now, if these words are similar, so my base word that I have here and this word at index J, if those are similar, well now we'll want to combine our groups. Either put J into group I or put I into group J. So first thing we'll do is check to see if we already have a group for our group J. We know we have one for group I, for word I, but we might not have one yet for word at index J. So let's check that first. So if the group for word at index J is none, we'll just make sure that it becomes part of the group that word I is a part of. So that's going to be groups at J is going to be equal to group at I. And at this point we could continue. Now if the word at index J is already in a group, that means a group I or word at index I and the word at index J, they each have a group. Now they need to be merged into one group. Now they might already be the same group, but we just want to merge these two groups together. So whatever's in group or index I, whatever group that word is in, is the same as the group that the word at index j is in. We just need to merge these two groups. So again, they might already be the same group, so we could check right away, just say if they're not the same, then we'll make them the same. So let's just do that. So if the word at index I is not in the same group as the word at index j, but we know that these two words are similar, that means we have to merge these two groups. So let's just write a function, merge groups. And we'll pass in I and j. Now we don't have this function yet, we'll have to create it, but that should help. So now we just merge these two groups. So we'll go through all of our words, we'll merge these two groups, and then at the end, we'll have to figure out how many unique groups we have. So we'll first write our merge groups, and then we'll figure out how do we count how many unique groups we have. So how do we merge our groups? Let's see, we're gonna have group 1 and group 2. Well, there are better ways to do this. I'm going to do this the straightforward way. There are better ways to do this. I'll point this out now. So if you want, you can optimize this function, and that will actually help in the end make this a better algorithm. So for me right now, I'm just going to say, well, I have these two unique groups. I'm just going to go through all of my group words, or all my groups in our group array here, and we're just going to choose whichever group we want. I'm going to choose the minimum group label, and we'll just make all of those labels the same. So let's see, how do we merge these two? All right, so for me, I'm going to make this common label. This is the merged label. So I'm just going to say it's G1 if G2 was none. If it's not none, then we'll just take the minimum of the two. Now, I think I will be able to do this because at some point we're saying if this is none, actually, I might not even need this none because we're already saying if this is none, we're going to set this group label. So we shouldn't actually end up having a none. Yeah, so I might not need that. Let's just do this for now. We might have to come back to that. So we have this common label. And now we just go through all of our groups. Okay, so this is pretty straightforward. We have this common label, which will be the smaller of G1 or G2. Now we're just going to go through the entire range of our groups. And if the group at that index is equal to G1, or if it's equal to G2, we're just going to set it equal to the common label. Now again, I pointed this out. This is not super optimal. There are better ways to do this, but this should accomplish the task. Okay, so we've got our three pieces here. We have one piece that will identify similar words. We have another piece that will go through, compare all of these words together and find their groups. We have another function here that will merge groups. If we find two words that are similar but are in different groups, then we can merge those two groups together. Now at the very end, we will end up with a list of all the group labels. Now we need to count how many group labels are unique. We have to find the unique number of groups. So to do that, I am just going to use a set. And then we will return the length of our set. So this will take all of the groups, let's see, singular group. This will take all the labels in our group array. It will basically just find the unique ones, and then we'll return how many unique labels there are. Let's see if this works. Okay, that works. Let's submit this and see how we do. Oh, and we get a wrong answer. So let's grab that, take a look at it. We're returning 6 when it's looking for 5. All right, let's minimize this and take a look at where we're going wrong. This is my problem. So I'm merging, these are the indices I and j. What I really want is group I and group j. I'm surprised that the others passed. Yes, so this is the problem here. It's group I and group j that I'm merging. So I need the group labels, not the indices of the I and j. Okay, let's try that. Okay, and that seems to pass. Let's submit this and see if we can pass all the tests. And we pass. We beat 19% for runtime and only 10% for memory, so it's not the best algorithm. Again, as I mentioned, you can clean up this merge a little bit. You can probably clean up all of this a little bit. One thing I'll point out, I didn't have time to go through it today, but there is an algorithm called a union find. Now this is a good problem suited to the union find solution. So if you are interested, I recommend checking it out. You can search for it online. There's different sites that will explain how union find works. But union find would be a good option for this type of problem. Okay, I don't have enough time today to go through any more, but that's it for me. So I hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.